Hello, welcome to this short video in which we would like to explain the basis of the stability of an SPMT transport. Let's have a quick look. Okay, here we see the 12 axle lines SPMT double wide, and the SPMT is fitted with a hydraulic system around the hydraulic cylinder, and each axle has a hydraulic cylinder being used to raise and lower the deck of the SPMT. Now, with this hydraulic system, we are able to connect these hydraulic cylinders. In this case, we have a total of 16 single cylinders being connected, and we are able to create one hydraulic bed. And it's a floating bed because all these cylinders are connected to each other. Now, we can do the same with the other 16 axles at the right side and at the front end of the trailer, and each bed can be operated separately from each other. And in doing that, we have a center of flotation in each bed, basically the center point of the hydraulic bed. And having this system in place, we call it a three-point suspension, creating a stability triangle shown over here. And in doing that, we have a system which best can be compared with a table with 3 poles. Now, as soon as we got a load on top of the SPMT, we have to make sure that this center of gravity of the load is always within this yellow triangle, within this stability triangle. And what is a measure for stability? That's the distance from the center of gravity towards the tilting line. So it's one of the sides of this triangle. Okay, here we see the same situation, but now also in front view, where we have the height of the center of gravity, and we have the distance from the center of gravity towards the tilting line. We will be able to define the tilting angle. And this tilting angle is a measure for the stability of the transport. Now, what's going to happen is that as soon as we, for instance, have some camber in the road, the trailer will rotate and the center of gravity moves in the direction of one of the tilting lines. So what you see here is that the center of gravity is now coming to a position beyond the tilting line, and you will simply lose the load, because having the downward force through the center of gravity, it will create a tilting moment. Now, it can be seen in this short video here, where we have a transport of a monopile, and as soon as we got some camber in the road or moving around a corner, you see that the center of gravity is moving towards the tilting line. And the operator with his hydraulic system is able to compensate and to level the deck of the trailer again. And that's also shown over here. Make sure that you will always be in this situation and avoid the situation shown here. Okay, we are back to the 12 axle lines SPMT again, and we now do exactly the same, but instead of connecting 3 beds of 16 axles, we now take a total of 4 beds of 12 axle lines. And the result is basically set up in the same way, where we have 4 points of flotation connecting to each other, creating a yellow rectangular stability area. And you can imagine that as soon as we put a load on it, it can be compared with a table with 4 poles. And having this load on the trailer, you can also imagine that the distance from the center of gravity towards the tilting line is much bigger than with the 3-point suspension. This basically creates a bigger stability and a bigger tilting angle than the 3-point suspension. Okay, what we see here is the 4-point suspension, but now in front view as well, with the center of gravity of the load at this position, and with the distance from the center of gravity towards one of the tilting lines and the height of the center of gravity, we can define the maximum allowable tilting angle for this system. And we have the same here, where with some camber in the road, the center of gravity will move towards one of the tilting lines when we do nothing. And what we have seen in the 3-point suspension short video is that the operator, in order to cope with this kind of situations, has to level the deck of the SPMT as horizontal as possible. Now, if we compare the situation with the 3-point suspension, it is obvious that in having this yellow rectangular area, that the result is much better with regard to the distance from the center of gravity towards the tilting line than with this 3-point suspension. Okay, now if the 3-point suspension system, the 8x8x8, is, well, not really the best solution for stability, we might opt for a different setup of your 3-point suspension. For instance, this might be a solution where we have a 2 points here and there, where we have a 12 axles being connected and 12 axles over here, and we have 24 axles being connected over here. And it depends on the position of the center of gravity if this is a better solution than the original 3-point suspension. So it's a matter of playing with your with your grouping, with the setup of your hydraulic system. Okay, here we have a complete different setup of a 3-point suspension, where we have at the left side of the trailer a bed of a total of 24 axles, and we go to the right side of the trailer 2 beds of each 12 axles being connected, and doing that we create a asymmetric 3-point suspension. And this triangle, well, it depends on the routing, it depends on the position of the center of gravity, if this asymmetric setup is more favorable than the original 3-point suspension. And in general, the preparation of a transport, well, it's easy to play with the number of axles per hydraulic group. Just check the stability by setting up the tilting angle, the maximum allowable tilting angle. And if the 3-point suspension is not enough, then you may go for the 4-point suspension. Okay, we hope that you now have a better understanding of the stability of an SPMT transport. If you have any questions, or if you are interested in a masterclass on heavy lifting and or special transport, just let me know by sending me an email to academy@eager.one and we will follow up. Thank you for your attention. Bye bye.